So we left off before break talking about squares. We're going to finish up the last page of squares by constructing a square. So you will need a compass and a straight edge to do that. And then we're going to jump forward and start talking about some trapezoid stuff. So we're going to go ahead and get started. Make sure you have your compass and straight edge. And here we go. So constructing a square with a straight edge. The first thing you want to do is extend out your side in one direction, either from A or from B. So I'm going to use my straight edge and extend this side out here. From there, I'm going to construct a perpendicular through point A right here. So we're looking at point A. We're going to make marks on either side. And then from those 2 points, we're going to swing arcs to make our perpendicular. So connecting through those 2 points, and we'll have our perpendicular. Then what you're going to do is measure from A over to B. So you're measuring that original segment that you had there. And you're going to measure from A, moving up that perpendicular and make a mark up above. So you already have 2 sides of your square now. You have the bottom and you have the piece going up here. Then we're going to go from B and we're going to make a mark somewhere up above it. And then we're going to go from this other point over that same distance and make a mark. And that's going to be the last corner of our square. So essentially this top piece here and this side piece match. So the last thing you have to do is connect those 2 points and connect these 2 points. And now you have a perfect square. So if you need to see that again, you can rewind it and watch it again, go through it. Otherwise, this is all the construction marks you need to have so that you have your perfect square constructed. So jumping on to trapezoids now. So a trapezoid is going to be any quadrilateral that has exactly one set of parallel sides. So you're going to have 2 parallel sides that are called the bases, and you're going to have the other 2 sides that are not parallel called the legs. And you need to make a note in here that angles on the same leg of a trapezoid are supplementary. So the same side, so on the left there, and the ones on the right are going to be supplementary. Now an isosceles trapezoid is a special kind of trapezoid. It's a trapezoid with congruent legs. So your 2 side pieces would be exactly the same. So this one down here is an isosceles trapezoid. So the special properties of an isosceles trapezoid is that the base angles of an isosceles trapezoid are congruent. So these 2 and these 2 would be congruent. And again, the ones on the same leg would still be supplementary. The second special property of an isosceles trapezoid is that the diagonals would be congruent. Trapezoids have something in them called the median also. This is a segment joining the midpoints of the legs. So if you're looking at a trapezoid and you see the 2 legs here, a median would break this leg into 2 congruent pieces and this leg into 2 congruent pieces. Now that one looks kind of like an isosceles trapezoid. The one on the right here, it would break these into congruent pieces and this into congruent pieces. And that one doesn't look quite so isosceles. But either way, the median is halfway down the trapezoid. It connects the non-parallel sides of the trapezoid. It connects the legs, not the bases. So the properties of a median is that it's 1, parallel to the bases, and 2, it is equal to half the sum of the measures of the bases. So what you're going to do is essentially average the bases, add them together, and divide by 2. And that will equal the length of the median. So for this one here, you would take your median, which is 3x, and you would say that that is equal to the sum of the bases, so 27 plus 33, divided by 2. And you could go ahead and solve that on your own. We're not going to do that right now, though. So for each of these, pause the video for a second and attempt to figure out what the median would be. Okay, so for number 2, we would take the median, which is 16, and that would equal the sum of the bases, so x plus 22 divided by 2. I'm not going to solve that out right now. For number 3, if you want to set up the equation, it would be the median, which is 3x plus 1, equals the sum of the bases, which is x plus 7x minus 2, all divided by 2. And again, I'm not going to solve that out right now. The next thing we want to look at here is just practice with trapezoids. So what I'd like you to do is pause the video, take a second and figure out if you can determine which property of an isosceles trapezoid is going to be used to find the value for x in each of these problems. All right, so for number 1, we're looking at this and we see that we have the 2 legs of this trapezoid. Well, we know the legs of an isosceles trapezoid are congruent, so we'll have 5x plus 1 equals 3x plus 11. For number 2, we're looking at it and we see that we have angles that are on the same leg. We know those are supplementary. So we'll have x plus 3x equals 180. And you would go ahead and solve that. And the last one down here, GM is going to be this diagonal, AE is going to be this diagonal, and in an isosceles trapezoid, the diagonals are congruent. So you would set 3x minus 5 equal to x plus 15. So the next thing we're looking at is going to be a proof using a trapezoid. So we have an isosceles trapezoid here with bases QR and ST. And we want to prove that QTS, so this big triangle here, is congruent to RST, this other big triangle that's overlapping it. So pause the video, take a second and see if you can get a few of those statements and reasons down. Okay, so I'm going to put up 2 different ways here that this can be proved. So the first way is going to take our isosceles trapezoid and we're going to say the bottom is congruent to itself by the reflexive property. We're going to say that QT is congruent to RS because the diagonals of an isosceles trapezoid are congruent. We're going to say QS is congruent to RT because the legs are congruent, and then the triangles are congruent by side, side, side because you have all 3 pieces of the triangle congruent. The other way you could do this is, again, using ST congruent to ST, using the reflexive property. Again, QS congruent to RT because the legs of an isosceles trapezoid are congruent. But then you could say that QST and RTS are congruent because the base angles of an isosceles trapezoid are congruent. And this would prove the triangle is congruent by side, angle, side. There's probably other ways to do this as well. I'm just showing 2 of the easier ways that only take 5 steps. So what you will be working on next, either in class or at home, will be the square worksheet that was in your folders. Other than that, I hope you have a spectacular day, and I will talk to you later.